Do 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 do. Do you hear that music in the background? Man, that brings me back to my days of playing the original Game Boy, playing Tetris. Tetris? If you've never played Tetris before, you should play it. I mean, for real. Tetris. What a game. Well, you know what we're going to do today? We're going to do a little bit of Tetris, or sort of. Well, this is lesson 3, session 3, so lesson 3C, if you want to put it that way, on describing sequences of rigid transformations. So we're continuing with sequences of rigid transformations, but now we're going to describe them. This is on page 55 through 57 in your book. Our 2 learning targets are listed below, but the one I really want to focus on is the second one, being able to describe a sequence of transformations that can map one figure onto another. So let's look at the problem of the day today and try to make sense of it first before we actually take some time to do it. So I'm going to read it through, and I would like you to follow along, and I want you to think about, first of all, what do you notice, and what do you wonder about, and maybe what's important for this problem. So it says Paula plays a game on her phone where she needs to fit shapes together. Figure J, which is at the top of the graph, will fit into J prime only if the figure space is congruent. The figure in the space is congruent. Now, if you look at it, you probably could figure out that it might fit. But what do you notice about it? What do you wonder about it? How can we get it from the one space right here to the space right there? I'm going to read it through again for you. Paula plays a game on her phone where she needs to fit shapes together. Figure J, right here, will fit into figure J prime, right there, or space J prime, only if the figure and the space are congruent. Describe a sequence of 2 transformations that would move the shape into its space. We're going to get this to there. If you just bring it straight down, I don't think it's going to fit. So we want to think about how we could get it to fit. And that's what I'd like you to do. So go ahead and try it on your own. And we'll see if your way to get it there is the same as my way or maybe someone else's way. So now that you tried it, how did you decide which transformation to do first? What did you do second? Will it fit? Were you descriptive enough in how you did it? So think about that. And let's try it. I'm going to show you one way that I did it. What I tried first is I recognized that this part actually had to fit in here. So it had to rotate. So it had to rotate this direction a little bit, and that would be clockwise, or you could do it the opposite, counterclockwise, but this would be clockwise, and it's 1/4 turn. It's not, if it was halfway around, it'd be over here. If it was 3/4 of the way, it'd be over. So it's only 1/4, which would mean it's a 90 degrees clockwise rotation. And that would be around the origin. Now, once you do that, there's got to be another way to get it from the space to here, and that would be a translation down. If you look at it, just counting, this needs to go 1, 2, 3, 4. So all of them need to go 1, 2, 3, 4 to get down to the bottom. So it'd be translate. Oh, sorry. Translate down 4. And I think that would get it into the space that you want it to get in. And it looks like it would fit too, right? We've got 1 on the bottom in the middle, 1 on the bottom in the middle, 2 on the middle row, which would be off to the right, and then 3 on the top row right here. So I think it fits. Now, did you try it different? Or did you do it a different way? This is another way that I thought to try it. You could start by translating it. Then you could rotate it around the origin. Now this one's a little bit trickier. I didn't visualize this one right away, because if you want to do it in two, I mean, you could translate it a little bit, rotate it, and then translate it again. But if you want to do it in 2, we'd have to translate it 1, 2, 3, 4 to the right. So it'd be a translate for right. The reason we got to go way over there is because if you are going to rotate around the origin, which is this, this center right here, when you rotate it all the way over here, it's got to be the same distance away. So right now, from the origin, it's 1, 2, 3, 4 spaces away, and we want it to be, come on. We want it to end up the top of it 1, 2, 3, 4 spaces away. We want it to go right there, which is why you have to translate it 4 to the right first, and then we can rotate it 90 degrees clockwise. And again, it's around the origin. 2 different ways gets you the same spot as long as you can describe those correctly. They should make it to the same spot. So let's go to page 57 real quick, and let's talk about this. Let's break it down a little bit so we can understand it a little bit more. So on page 57, let's start with these questions. All right, number 1 says, look at both picture it. So the 2 different ways we did it on the other page. Explain how the figure was transformed in each. Now, we wrote it on the slides. We don't have to say it both ways, but one of them we had a rotate, then translate, and the other one we did the opposite. So for the sake of writing, I'm just going to summarize that. As long as you wrote it on the other slides, otherwise if you didn't do that, make sure you write it in here, because we did a translate and then a rotate for the second one. Now maybe you found another way to make it work, but be careful that it's always like the distance and the rotation of everything is accurate. Let's go to number 2. Look at the longest side on figure J and the corresponding side on figure J prime or double prime. So I'm just going to say like here, the longest side on figure J. Let's get rid of all this, which would be on the left side right here. And then if you look at our figure where it ends up in J double prime, it should be on the top. So the question is saying, looking at that, are the sides horizontal or vertical? So I would say for that one, for J, it's up and down, so it's vertical. And J double prime, it is horizontal because it ends up being on the top, so it goes left to right. How could this help you decide whether or not to include a rotation in the sequence? Well, if you do a translation or a reflection, it's going to stay the same direction. It's either going to be going left to right or up and down. In this case, the only way for it to switch would be a rotation. So we have to and do that in order to turn it. Number 3, why is one rotation around the origin not enough? Why is one rotation around the origin not enough? What else is needed? Well, if we just did a rotation around the origin, it wouldn't be far enough away from the origin. We're going to say it would not be the same distance away from the origin, or not be far enough away in the end. So, like you can see in the picture, if we rotated it, like if we rotated it first, it ends up right here. Sorry, it ends up right here, which is not far enough away from the origin for where it needs to be. It needs to be down farther. So in order to do that, then we have to also translate it. We could translate it first, or we could translate it second. So what else is needed would be a translation. All right, number 4. Is it possible to map figure J onto J double prime if one or both of the two transformations in the sequence is a reflection across an axis? Explain. Now, if you found a way, that's awesome. If you could find a way to do that, then that's awesome. Maybe I'll go back to here. I mean, I would say yes. If you did like another reflection, and it would have to do more than, it'd have to be more. That would change the orientation. So really, it would be no, unless you did 2 reflections. Plus, you could do a reflection that way and a reflection that way. Well, plus more transformation. So I think it would take a little more than that. So the main reason it wouldn't work is because it would take more than 2 transformations. So number 5, how can comparing a figure and its image help you describe a sequence of transformations that shows the 2 figures are congruent? Well, big thing here is looking for corresponding parts. If you look for corresponding parts, it helps you figure out what transformations, helps to find the correct transformations. And one example of that would be how we talked about in our example, the fact that, let's see, I didn't use it here, like the longest side. We knew it was on the left, it had to be on the top, so it had to rotate. So looking for the corresponding parts will really help to find what transformations would work, and then if it would actually be congruent. So corresponding parts is key there. And then number 6, I'd like you to try to answer on your own here. Think about all the models we discussed, strategies we discussed. Now, we really went through 2 of them, and we kind of thought about how we could do a reflection. But if there's any other things that come to mind, think of those 2. Describe how one of them has helped you better understand how to solve the try it today. So which one was the easiest for you to understand this example? All right, I'd like you to try that one on your own. And then I'm just going to wrap it up here with bring us back to our original learning target of describe sequence of transformations that could map one figure onto the other. And yeah, it might have to do with graphing just to play around with it, but we're trying to find now what ways could you get using 2 transformations from one shape to the other, and would it still be congruent? And that's session 3 of lesson 3. So lesson 3B, or lesson 3C, sorry. Have an awesome rest of your day.